But let's start with a bit of text about me. My name is Kasper. I work for a company called Ortec. What we do at Ortec is we help our customers with business processes, and we try to make those processes smarter. And typically that means we build and we implement a kind of a software tool. Sometimes that's a small tool. It can also be a much bigger project, and then it becomes a whole tool suite of software. But I think almost always there is some kind of core that involves mathematics or data science or machine learning or optimization. I have a background in econometrics. And I always liked programming, so I actually started that before I started my studies with econometrics. But that means that at Ortec I have it's kind of like a very nice playground to get into these topics. So I've been at Ortec for a little over 10 years. And in that time I've gained experience in all those things like data visualization and building machine learning models, but also what it means to take those things, not just build them for yourself, but actually take those into production and have people at the customer actually work with this and make it so that it actually improves decisions that we make. So much more on the practical side and maybe less on the theoretical background. Then recently I moved from, it's still in the Netherlands, so it's a small move, but I moved from the northern part of the Netherlands, from Groningen to Nijmegen. But lucky for me, there's still a bar with the same name. And so not too much has changed. Okay, let's get into it. So the first hour or so of today, we will be talking about version control. Version control is a way of solving this. So I think this is familiar to people who have worked with Excel before, or in businesses with larger teams of people. Typically what you see happening is you work on something, you develop a nice workbook, you share it with someone, but then you also want to continue development. So then you just copy it and you name it version 2. And then someone else has review comments. They also changed it a little bit, and you try to merge the changes that they made and that you made, and you call it final. But of course, it's not really final. So then it's final version 2, right? So this happens. You get these versions of Excel workbooks over time. You just copy and paste files and change the name, and at some point it will be a big mess. So the whole idea behind version control is to solve this, to not do this. But to do something else. And actually what we try to do here on the left side is, of course, there's different versions of the same thing. So we're developing something and it evolves over time. And actually then what version control allows you to do is keep track of those changes over time. That's the idea behind version control. So we'll dive into one specific version of version control. So maybe good to know that there are alternatives. There's many ways to do version control. Popular ways include a tool called Perforce, also Subversion or Mercurial. I think nowadays by far the most popular is Git. So today we will focus on Git, and actually also GitHub. And what are the benefits of using version control in general? Well, of course, there's then only one version of the truth. So you don't have these all these Excel files and you don't know which one is the latest one. It allows you to track changes over time, but it also makes it much easier to collaborate with other people. So that's a reason why we want to do version control. And of course, then you can go back to a previous version if that's needed. And the reason that we focus on Git, well, like I said, it's by far the most popular nowadays. And I guess it doesn't hold for everyone. I am Dutch, not everyone here is Dutch, but I guess everyone does like free things, and Git is free. So that's also good. It's free to use. So what is Git? Now, Git in itself really is just a set of command line utilities. So like you saw, I was on Windows, but suppose that you were on Linux, then Git was already installed, and you could open a terminal and you can type Git, and then it works, then you can use Git. So Git in and of itself is really just a set of command line utilities to help you do version control. I think I can also show you this. You see the terminal, right? I shared my screen, so you should be able to see this black thing. If I do something like git version, then it says, well, you are using git version this and this. If I know all these commands, then I can do a git clone or git help. So these are all the things that git can do. Right, so git in and of itself is just this command line utility, but that's not very user friendly. So we won't be teaching you how to use the command line and how to use all of that stuff. And luckily, we also don't need it because there's a whole ecosystem around Git. For example, there are platforms like GitHub, but also GitLab and Azure DevOps. And all those things are platforms that make use of Git. So they have their own source, their own version of it, but the basis is always Git. And then they add some stuff on top of it to make it easy for us to use or to try and make it more attractive. But so, for example, GitHub, which we'll dive into later, is an online platform, which is also free. You can make an account for free, and then you can make a repository and then you can store files online and actually use Git with it. But the same thing you could do for GitLab. So at Ortec a few years ago, we were still using GitLab because I don't know, someone chose that the IT people chose that was a good decision. Also, maybe put it in the chat. Let's see, very familiar. If there's a question, then you could also put it in the chat. I'll keep an eye on it. But lucky to see that the first slide was familiar to Marike. But so I was saying there's a whole ecosystem around Git, and so there are online platforms that you can use or that you will maybe find companies use. But there's also clients. So on your own computer, you have to install some version of Git, so the command line utility. But there's also other programs that make it easier to work with Git. I think I put in the preparations that if you install SourceTree, that's the one that I like. It's a free tool. It works with Git, and I'll show some examples of using SourceTree. But this one is quite good. And of course, there's also if you work with code, then you probably also have a code editor. VS Code is a very popular one, and then even from within the editor, you can use Git. So basically, those are all different ways of using Git, but the basis is always the same. So we'll try to start with explaining the basics. So what I try to capture here are what are the main concepts that you need to know when you're working with Git. The first thing, I actually already used it, the word repository. So a repository, that means it's a collection of all the files and actually also all the change history that belongs to your project. So if I'm on Windows, I can have a folder like this that has files and folders with files, and you could call that a repository. And then actually what you see is that in that repository on your computer, there will be a hidden folder, which is called git.git. And in that folder is actually all of the change history. So you don't really have to know this. You never go into this folder and do something. That's what Git is for. Git manages this for you. But it's good to know that actually what Git is just a hidden folder with all of your project history inside that. And you can use the tools that Git offers to track this history and to build up this folder. It's also good to distinguish this that we're seeing here. It's just a local folder, right? It exists on my computer. I can open a folder on my computer and then initialize Git and use it, and then that folder becomes a Git repository. I can do all of that. I can use Git, and I don't have to have something remote, something online. Git also works with just one folder on your computer. I'll show an example of that. But very often, of course, what we use is there is something on our computer, and then there's also something online. And that makes things more safe, and that also allows us to collaborate with other people. So that's almost always how you would use Git. But it's good to know that that's not necessary. You can also just use it on your computer. And actually all of the work that you do, so when you're working on code or on some kind of development project, all that stuff happens on your computer, right? And then we use Git to do synchronization between what we do locally and what needs to happen online. So that's why it's good to distinguish between this local repository and a remote repository. That's typically what they call it. And I'll show an example of this later in source tree. So a repository is just a collection of files that we want Git to track. Then the next few terminology, the few concepts that we need to know about is what is a change and what is a commit and what does it mean to do staging. Well, a change is simple. So we say that a repository is just a collection of files. Well, then a change means I added a file or I deleted a file or I changed something in an existing file. And that's a change. And a commit, that's what they call a collection of changes. So one commit could be something like I added 3 files and I made some changes here and I deleted something. And that whole collection, that's what you call a commit. And within a commit, you can also add a description. So for example, the first one typically says initial commit. And then the second one can be something like I changed the README file and I added some code, right? That could be a description. And then the commit itself could be changes in the README file and some additional code files. And then staging, that means that's the process of you ask Git. So you did something locally, that's without Git. You have a project folder and you open a code file and you make changes and you save the file. That's without Git. That Git has nothing to do. But at some point you open Git and Git sees, oh, these are all the things that changed. And then you should be the one to say, okay, I want to keep this and I don't care about this, right? That's what they call staging. So it's kind of a selection process of these things I want to pick and make it into a commit. So this also means that there is some kind of workflow involved. Typically, you just go to the folder, make some changes. Then at some point you think, oh, I want to keep track of this. This is useful. And then you do staging, and out of staging actually comes a commit. And a commit you can think of, it's kind of like a timeline. The project that you have and all its files, they evolve over time. And a commit would be one point on the timeline. So you decide what useful points on the timeline are. You could wait, you could do all kinds of development and wait for 3 days. And then we have a whole bunch of changes and make that into one commit. And then you say, this is a new version. Or you can do every single small change and have hundreds of commits. That's up to you how you want to do it. Git doesn't really care. But using this process, you build up a timeline and you can go back and forth in different points on that timeline. So all of this stuff, all these words, a repository exists locally on your computer, and doing a change, staging, and commit, that also happens on your computer. Nothing has to do yet with something that exists online. But suppose that there is also something online, and I see in the chat that there's some questions are starting to pop up in the chat, and the questions are mostly about showing examples, and I will definitely show an example of all of this later. But I think it's good to first cover the terminology, and then I'll come back to the terminology in the examples. And the terminology that we had so far is repository and change, commit, staging, and that stuff all happens locally on your machine. Then suppose that there is also a repository that exists online. For example, we use GitHub, and our project is also in GitHub. That means that it's now in 2 places. Then you have a remote repository and local repository, right? Online and on your computer. And then you need additional concepts. So for example, clone would be, it exists online and you also want to have it locally. Then you can clone it, and then the stuff that existed online now also exists locally and you can make changes to it. So if you start on a project which is not your own project, then indeed you can do a clone, and that will make files on your computer. It will kind of copy the project to your computer. So we had clone, and then there's a word called fetch. And fetch, that means, so these are the words that you need when there are two repositories, something online and something locally. Ivan is asking, what is the difference between a commit and clone? Well, a commit is just a collection of changes. A commit is something like, I added a file, I made changes to a file. So that's what a commit is. It's just a new point that you create on the timeline. But actually, a clone means clone is more of an action. Clone is what you do when something exists online and it doesn't exist on your computer yet. Then you would clone it from online, and that actually makes it so that the files also exist on your computer. Fetch means, and so something exists online, something exists on your computer. Fetch means do an update. So it doesn't change any of the files on your computer, but it tries to see if there are things that exist online but don't exist yet on your computer. Without actually changing any files, it just sees, okay, did something change on in the timeline? Are there new commits that someone else made online that you do not have yet locally? That's what fetch does. And pull actually does make changes to your files. So fetch actually just sees, something new happened, and you can see what happened, but you don't actually see the changes on your computer. Pull actually takes those changes and makes changes to the files on your computer. So clone you have to do first if it exists online and it doesn't exist yet. And after a clone, it exists on your computer. And then pull means, okay, update the stuff that I have on my computer, update these files so that they match with what is online. Right? And push is then the other way around. So pull means from online to your computer, and push means I made a commit on my computer. I made a new timeline, a new point on the timeline. Let's push it to the online version, to the remote repository. So these are the concepts that we need to know about when we want to work with two repositories, online and on your computer. And then you can imagine that something that might happen is you clone a project. That means now you have files on your computer that also exist online. Then you make changes. Maybe you downloaded a nice README text, nice piece of text, and then you make changes because you think, there is a spelling mistake in a paragraph, and let's also add some text here. So you make changes to those files. You make a commit. So you have a new commit, and now you want to push it to online. But in the meantime, someone else also made changes and also pushed that online. So that means that you made changes based on something that you got from online, but then the online version changed by someone else. And now you try to push your changes. Then it says that's not possible. It will give you a conflict. So as soon as you start working with more than one person in Git, then it might be so that you get conflicts because you're working on the same thing and maybe you accidentally changed the same thing. Could also be that someone else changed the README file and you changed a whole different file, then Git doesn't complain. Git knows how to deal with that. But as soon as you start making changes in the same file, and then actually it's a little bit smarter than that, but if you make changes that conflict with each other, then you get a conflict. And then what you need to know about is how to resolve conflicts. And then things can start to get a little bit messy and it can get complicated. So sometimes people say Git is very complicated. It can be very complicated. If you work with a whole bunch of people on Git, then there's all kinds of different strategies for how you should use this, how you should minimize the conflicts that you get, or how Git should merge different files. That can make it complicated, but really we don't care that much about it. It's fine if we start with these simple concepts. Then we can already use Git and we can actually be useful with it. We can be productive with it. And only if you start to enter more actual development teams, and then as soon as there are more and more and more changes happening at the same time by a whole group of people, then things start to get difficult. But this, even though there are lots of new weird words, it's really not that difficult yet, and I'll show you that in a moment. So we talked about resolving conflicts. That's when you change the same thing. You did it and someone else did it, for example. They also introduce a concept called diffing. And diffing means I can show for the same file, I can actually show the changes that happened over time. So then you show the difference between two files. And the thing that Git keeps track of is something like, so Git knows, for example, that you added a file and deleted a file, but Git actually also goes into the content of the file and sees, oh, you added a line and removed a line and you changed the line. So that's what Git keeps track of, all those changes, all the increments that you do. Okay. And finally, I put these on a little bit lower. So I think if you just get started or if you use it on your own, then you don't really have to know this. But as soon as you start working with more people, then it makes sense to know about branching and merging. So I said that Git is like a timeline. And we have a project, we have a bunch of files, and we make changes to the files. We do a commit. That means that all of these points, this is drawn like a timeline, right, from left to right. And if we look at the middle line, then we see that there are points on this line. Those points are the commits. That's also often how it's visualized. So if you don't use the terminal, if we're using source tree, then source tree will actually also show us this in a graphic way. And it will say, well, you have a branch, and that's this timeline. You always have one branch, the default branch or the master branch or the main branch. That's the default one, and that's the one that keeps track of. I have a bunch of files. I make changes, and then I make a new commit. Then this is the first commit, and this would be the second commit, and this would be the third commit, and so on and so on. Branching means that you can actually branch off and create a new timeline. You say, well, why is that useful? That seems difficult. Why would you want that? Well, the reason that you would want it is because now what you do in this timeline actually doesn't affect this one. So if you work with more than one person, if you're working with a team of developers, then it makes sense that you have a master branch with a version of your project that's working. And then maybe you want to add a new feature because we're programming or something. Then we split off. And then you start working on a new feature, but probably the first commit that you do, it's not finished yet. So probably the first commit that you do, maybe you actually broke the software. That's fine, because it doesn't actually affect the master branch. Right? So that's why it's useful that you can create a new timeline, and then you can work on your own timeline without that it matters to the actual timeline. You can work on it on your own. You will never have conflicts because you're the only person working on this. And then at some point you will have done a number of commits and you think now it's done. Then you can actually merge it back into the main. And
can I ask a short question?
Yeah, go ahead.
So always when you try to clone, fetch, pull, or push, it creates a different branch?
No. These words, clone, fetch, pull, and push, only mean I do something with the remote repository and locally. It has nothing to do with creating a new timeline or a new branch, or that's always within a timeline. So doing push, for example, would mean that all of this stuff could exist on your computer, the whole timeline and all the branches and everything. Then you could make a new commit. You can do that on your computer. You can make changes to a file and say that should be a new commit. Then on your computer, there will be a new point here on the timeline. But that doesn't mean that it exists online. So if you want that thing to also exist online, then you need to do push.
Yeah, clear. Thank you.
Right. And the other way around is if someone else did something online and you want to have it, then you need to do pull. Okay, so let's go over a few of the questions that are now in the chat. Helene is asking, would you say the master branch is remote and a personal or local? No, that's not the case. And I think that's a similar question to what Mariah had. So actually all of this stuff, all of the branches and all of the history actually exists remote. And if you want, all of that stuff at the same time can also exist locally. But those are really two different concepts. So a repository can exist on your computer And on your computer, you can make branches, and you can do merging, and all of that stuff you can do on your computer. And that's all within one repository. And then to make it more useful, you can also add a remote repository. So those are two different concepts. Branching, making branches and merging them back has nothing to do with the fact that it's either remote or locally. But I get why that could be confusing.
Quick follow-up question. Is it then not very complicated if you create a branch and then someone else maybe starts to work on your branch, or that doesn't happen?
Well, Git itself does not prevent that, but that never happens, because the whole reason that we use branches is to prevent this from happening.
Yeah,
So
exactly.
typically what you would do is make a branch and say, this is branch Helene trying to fix a bug. And I would make a branch Kasper adding a feature. And then it will be weird for me to go into your branch. So in practice, you never do that. And in practice, what happens is that everyone, for example, has this main branch. So all of this stuff exists online, but maybe locally, I only have the one branch. Because I don't have to pull everything. I'll show that in a moment, but I don't have to pull everything to my local machine. I can if I want to, but it's fine if I only pull the one branch and work on the one branch, and that works. Then one person, or at least a couple of person, I don't know. No, it's always Hassan. Hassan really wants to talk about rebase, and I'm going to have to disappoint Hassan, because what I've actually already told you about is that Git can get complicated if you want to. And actually what I want to show you guys is just one way of working with Git, kind of the most default or the most used way of working with Git. And it's good to know that there are different ways of working with Git. And rebase is indeed also one of the functionalities that Git has, but you don't really have to use it to be productive with Git. So for now, I want to stick with the basics, but maybe later I can come back to rebase. Let's see. The slides will indeed be shared afterwards. Will my data be secured? Well, so actually the fun thing is that it's secured in the sense that you don't have to do anything remote. So the only thing that it would be unsecure is if you create a project and then you push it to somewhere online and then you give everyone access. That's up to you. You don't even have to push it online. If you keep it on your computer, it's secure. So you can do version control, right? That's the goal. We want to do version control, and you can do version control without having anything online. If you do put it online, then of course in GitHub, for example, you need to be careful. If you create something, is it public? Then everyone can see it. Is it private? Then only you can see it. Then you control who can see it. But that doesn't have much to do with what we're talking about now. That's more about, well, where do my projects live? But these terminologies, these things, they are secure in the sense that it's just something that happens on your computer. Git itself is not an IDE. So Mohammed is asking, is Git an IDE? The word IDE stands for Integrated Development Environment. And no, because Git itself is really just this simple thing that I showed. This is Git. It's just a command line utility. It's just a small program that you can install on your computer. That's not an environment or something. You don't program inside Git, right? It's not an editor. It's just a tool. Git has a limitation for large files. Yeah, so sometimes you would read about Git, and then people, of course, also have downsides about Git. So there's many alternatives, right? So why do those alternatives exist if Git solves everything perfectly? So sometimes you see people saying, well, Git is nice, but because Git looks into your files, Git can become slow if you have very, very big files. Normally, that's not an issue if we're doing programming. We're working with code files, and code files are just text files. And those text files are typically very small, so not an issue. But sometimes people are working on something very different, like video. Maybe you want to use version control for video editing. Maybe Git is not such a good option. For now, we don't really care about it because Git is a good option if we're doing code. And then actually you can also make Git more complicated. So there exists something that's called Git large file storage. Like a plugin, we can make it more difficult if we want to. And then suddenly Git can help with larger files. I have sometimes used that if we also want to store, for example, data files inside of Git. So if we have a project and we're working with data or data analysis, for example, then we have the code. The code we definitely store in Git. And then, okay, there's sometimes some discussion on, do you also store all the input files and all your data in Git? If you would want to use LFS, large file storage, then you can put that inside Git. Is it possible to make my code online? Yes, you can choose what you want to do online and what you want to do locally. So inside of a project, you can say, don't track these files. Right? So you don't have to do everything that exists on your computer, doesn't have to exist online. There's a question to Git create a new branch during a pull request. So the word pull request we haven't seen yet. And I'll cover that a little bit later because pull request does not belong to the basics of Git. This is the basics of Git that's now on the screen. So maybe let's continue with showing this instead of talking about this. So what I can do to make things a little bit more clear, this is my computer, right? What I'm going to do is make a new folder. Let's say this is my project. And could be that I have a file in here. File in here. I could do something like okay. This doesn't make sense, right? It's just one folder. There's a text file and there is hello in the text file. It's not code. It doesn't work, doesn't matter. It's just a file. But this I can do just locally. Now what I can do is open source tree. No, don't need it. Okay, so now I am inside of source tree. But this is the program source tree. So what I could do is I can say create a repository. I say it's this thing that I just created, my project. This is it. This is what I want to be a repository. Yes, this is what I want. Okay, now I have a repository. That's it. Then you see what it did. It actually created this folder that we talked about. Normally you cannot see it if it's because it's hidden. But I show the hidden file, so we can see this hidden folder, and it does some stuff in here. We don't care about it, but this is how it knows, right? This is where my history is. Okay, so this is my repository. Now Git says, hey, I see that there is something. So here it says unstaged files. It says, hey, I see a file, and it's not part of my timeline yet. Which makes sense. We just created this. So it says unstaged files. So what I can do is I see all of the changes. There's just one file, so there's just one change, but it sees everything. So, okay, we say stage this. So now here on this screen, it shows this is what I have staged. So this is the process that I talked about. I made a change and now I'm staging and I did a selection. I say this is what I want to stage. And this is what will become my commit. So if there would be more changes, I can stage more or remove it. So I can have a process where I do a selection of what I want to keep. And then here I can type a message, my first commit. And then I can press a button that says commit. That's it. So now we see this. Now my repository has a timeline. It also has a branch, right? It says now master branch. So if I look at this tool, then here on the left side, it says a workspace, a few things that I can click through. And then I'm inside of a repository and it says this repository has a branch master, one branch. And we see that this thing also shows my first commit. That's about it. This is about it. I cannot do more here because all of the changes that I made are now inside of this timeline. So this is it. Now what I can do is I can go into my project. I could close source tree. We don't care about it anymore. I just go in and make changes to my code. So I do this, and I also add another file. Okay. So now so this could be some useful work. This is not useful at all, but it could be useful. And then I go back. So I open the project again, and then it sees in the file status, it sees, hey, things have changed. So I can go in here, and then it says, hey, this line was removed, and these lines are added. I don't know actually why it thinks that the line is different. I think because there wasn't a new line. Probably here it says it was hello without a new line, and now it's a different line. It's hello with a new line. And then there's this. So it sees the changes in this text file. And it also sees, hey, something happened here as well. So I could do this. This is what I want to add. And up to me, maybe I don't care about this yet. Maybe I do care about it. We could say, it's empty, so let's not add it yet. So here I can write a message, change to my code. And I can do commit. Same thing as before. Now we see there are 2 points on this timeline. This is source tree. I am inside of the repository, my project. Then there is still one branch. It's the master branch. And then in the master branch, there is this timeline. And we see that there's 2 points on the timeline. There's my first commit. I changed my code. And then it says, oh, there is also something that you did not commit yet. This is a potential point. It doesn't exist yet. I can click on these things. I can see the text. I can see when I committed it. I can see what it actually changed. Right. So this is version control. It keeps track of all this stuff. And still, it's a little bit up to me to make sure that this makes sense. But you can imagine that if you're doing development work, then this is useful. You can say, oh, I tried to fix a bug. Oh, I added a new feature, right? Those can end up as your commits. Okay, so let's see what else we can do. Well, what I could do is I can create a branch, right? We said that we can do branching. So there's a button here that says branch. I can type this. So this is the name of a branch, Kasper, my name, and then what I think that I will be working on in this branch. Could be something like this, fix bug. Okay, create a branch. That says this. Now there are 2 branches. There's the master branch. There's also this one, fix bug. If I double click, then it switches between the branches. Double click here. It's the same as saying check out. Double click, and then it switches between the branches. But the weird thing is that I can see in source tree using Git, I can see this whole timeline. I know that all this stuff exists. I don't see anything like that in here. Right? There's one set of files on my computer, one set of files for the project. I don't see in these files whether it's the master branch or the fix a bug branch or which commit or something. That doesn't work like that. It's just one set of files here. And using Git, I can control these files, the files that belong to the project. So now what I could do is say, okay, I go to the branch fix a bug. And then I could go into my code and I can say, here's my code. And now the bug is fixed. Okay, save it. I'm inside of this branch. File status, and then it sees, hey, my code has changed. So let's commit this. Well, okay, so now I do commit. Okay. Now we see that here it says my first commit, change my code, And it also says fix the bug. But we also see these tags. Here it says the master branch is here. Change my code. This branch is here. Fix the bug. Let's see if we can also get. You could choose, there's a lot of settings inside of source tree that allow you to, if things become more complicated and there will be many branches, then things can get messy, and then you can control what you want to see. But you see that I fixed the bug. But I also know that if I go here, so if I now go back to master, master's here. That means that now, if I open this, there could still be a bug, right? It's not here, it's gone, the line that I added. But if I go back here and I double click on fix a bug, now I open the file, there the line is again. Right, so source tree actually manages these files. Source tree, Git, it uses Git underwater, but the program is called source tree. I use this to control what files I want to see here. You could say what version of the project you want to work on. So maybe I actually
now then eventually merge the fixed bug branch into the master branch.
Yes, indeed. At some point, because it could be that actually I thought I fixed it, but oh, I did not fix it, and I actually need a little bit more. Oops, actually now it's fixed. Right? Maybe I added a little bit more. I tried something, I tested, ah shit, it didn't work, and then okay, so I make a lot more commits until I like it. Now there could be 2. This is a bad name, but that doesn't matter for now. Now we see here, oh, there's the master branch, and actually this branch even has 2 new things, and at some point you can merge. So I can choose to merge. Let's see. And it says pick a commit to merge into your current branch. This wouldn't be too useful because now I'm still in fix a bug. And if I do merge from here, then it says pick a commit to merge into your branch. There's nothing I want to merge into fix a bug. That's the newest one. So it's actually the other way around. So then I would go here, and then I can do merge. And then I can say, oh, this one, this is what I like. This is a commit, and I want to merge this into my branch. Okay, there it is. So now the master branch has all the commits. And we can see that because this tag master is the same, it's on the same line as this. So now the master branch has everything. So now I can open this, and then it says, all of the lines are here. And now this branch is not so useful anymore. So I could say delete it. So now it's gone. And all the commits are still here. But this is a very nice way of working with it. And what's also nice to recognize is that all these things happen locally. There is no GitHub. There is nothing online. It is secure. It's just on my computer. It's just a nice way of keeping track of files. Go ahead. Okay. But there is a question here that says, can we restore previous file versions? Well, yes, so maybe this was actually a bad thing and I did not want to do this, actually fixed it. Maybe that's bad. So what I can do is go to this version. I can say reset to this commit. There's also a whole lot of other options. There's also the rebase that someone wants to talk about. Well, what we can do is reset to this commit. And then it will ask me, okay, if I do that, then what do I do with the changes that were made since this commit? So you can say, okay, I want to keep all the local changes. Or you can say discard it, just go back, and I don't care about all the stuff that happened since those commits. But this is actually a nice thing. So now those are reset. Commits are not there anymore, but it sees this. So that's what I did. So what it actually did is it said, okay, fine, I will remove those commits. That information doesn't exist anymore in Git. It's gone. But I will allow you to decide what to do with the changes. So these are all the changes that were made since the thing that I reverted to. But I kind of went back in time, but I still kept those files on my computer so that I can now decide what I want to do with this. But it's a safe thing to do. And I can decide, shit, no, I actually do want to keep it. Then I can make a new commit again. Or I can say, yeah, this was actually correct. So what you can also do is here discard, meaning that Git saw these changes. Up to me, I can also say discard. I don't care about it. Let's discard it. Now it's really gone, right? I went back in time. The commits don't exist anymore, and the changes in the file also are gone. So this is how Git works for version control. You make commits; those end up as new points in the timeline. You can make branches to create new timelines. That's just a way of saying, okay, these commits will end up here and not on the main thing. That's useful if you work with multiple people, because then you reduce the number of times that you get into conflict because you change the same thing. And you can understand that there is you can come up with a workflow. So if you work with a team of people, then you can make agreements and say, okay, this is always how we name our branch. We only want to merge it into the main branch if it is also checked by someone else, right? You can make agreements on how you want to use this tool so that it works for your team. And then especially around when do we create a new branch and when do we allow a branch to go back into the main branch? That's something that you typically make agreements on within the team so that everyone works in the same way. And you see that at some point you have to choose something like, okay, if you reset it, what do you do with the changes? And if you do a merge, something that Git allows you to do, what you actually saw when I did the merge was that all of the commits from my branch ended up in the main branch. So if I would have done 100 commits, and then I did merge, then in the main branch, there would be all those 100 commits. But some people say, yeah, I don't want to see 100 commits in the main branch. I don't care about all that stuff is intermediate work. It was useful for the guy who developed it. I don't want to see it in the main branch. So what you can do is actually, when you do a merge, you can also choose to squash it, meaning that all those commits are just combined into one big change. It's fine, it's just a strategy. Well, if the team wants to do it, if you want to do it, fine, go with it. If you don't want to do it, don't do it. And then rebase is also one of those strategies. You can say, well, instead of actually merging these changes that I made, all of those 100 things, and merging them back, what you can also say is, well, actually, if something changed in the main branch, then the nicest thing to do was make a new branch. Then on top of that new branch, do all of my changes, put it on top of the new branch, and then directly merge it back. It's a choice. You have choices. What do you want to do if you branched off and someone else also changed the thing that you branched off of? What do you want to do? Well, there's choices, and the choices that you make in the beginning, they don't matter. It's just a tool. If it works for you, it works. Who cares? But as your team grows bigger, if you make more and more and more commits, if you're doing a development team of 100 people, and you use Git, and you want you use it, for example, to develop YouTube, I don't know, something very important, then you want to spend time and figure out how do we minimize the amount of conflicts that we get. In the beginning, we don't care. And indeed.
Kasper?
Yes.
Can I ask a question?
Yeah, go ahead.
What you have done so far, you have only in your computer, right?
Yes.
You don't have the files in a GitHub.
Yes, it's nothing to do with GitHub. We haven't seen GitHub yet.
Yeah. But if you're going to work in a team, you need the GitHub.
Yes, because what I've shown so far only works for me, only for one person. But this doesn't allow me to share it with someone else. So indeed, the next thing that I want to do is go to GitHub.
Yeah.
Right, to show, but it's good to know that Git itself is only here.
Yeah. When you have a GitHub, when you do the commit, you have to do the push.
Yes, because otherwise it only exists here. Oh,
Yeah.
you already see a hint. It says here in source tree, it says remotes. It's empty, there is no remote.
Yeah.
But if I would now also go into GitHub and make a project,
Yeah.
I can synchronize the two and I can say, okay, whatever exists here, I want to be able to push to GitHub.
Yeah.
And the other way around, I can go into GitHub and find something and clone it so that it exists here.
So I don't get, when you don't have a GitHub, it's only
Yes.
you
Yes.
working in your computer. Why do you use commit?
You use commit to make a new version. So without a commit, it's never possible to go back.
I see. Okay.
Right,
Okay,
so
thank
commit
you.
is like in the original, if you would say copy paste the Excel file and give it a different name, that's a commit.
Yeah.
It is something that you think this is useful, and maybe I want to go back to this version at some point.
Okay, thank you.
Okay, so let's also then make it a little bit more complicated and go to GitHub. It's actually not that much more complicated because GitHub, let's find something. Hello world. GitHub, hello world. Not this one. Here we go. This is a GitHub repository. Okay, so this is GitHub that we're seeing here. So this is also a repository, and this repository only has one file because it's a simple repository. It's only README, and inside of README is hello world. But we also see a few things that we already know about. We see that this is called master, and here I can see that there are branches. Right, so all the stuff that we learned so far is also here. There's three branches. There is this master branch. There's commits. Here it says commits. If I click on it, then I see a timeline. It looks a little bit different, but it's the same thing. So GitHub just offers you a repository that exists online. And suppose that I think this is useful and I want this thing, this README file. And I can actually say, I can go here, the button, and it says clone. And then there's a link. Right, this link. I can copy the link. I can go into my source tree. Where is my source tree? Here. I can say a new repository and then clone. In here, the source will be this thing. And then it says, yeah, that's fine. We can do it. I don't want it here. Let's say I want to have it here. Hello world. Okay. Clone. Okay. So this stuff didn't exist on my computer. It only existed online. I use clone. Now it exists on my computer. There's the file. There is the Git folder. Now I can start to work together because now I see, hey, there is a remote. The remote says this exists online. This is GitHub. This is what happens here. Now I can do fetch to see if something happened. So fetching means update the timeline. And then it says, yeah, nothing happened. Well, luckily I just cloned it. Would be weird if something happened in the meantime. But suppose something did happen. Then it could be that I am not on the latest master branch. It might be that the master branch that is online has changes that I don't have. Then I can do pull. Pull means get those changes and make sure that they're here. And push is the other way around. If I now make changes locally and I want that to end up in GitHub, then I can do push. Those words, so these three, pull, push, fetch, only have to do when you're synchronizing between online and your computer.
But if you want to do push, you have to be allowed to, right? You have to be
allowed, yes. So there's also someone owns this repository. And like I said, GitHub adds something on top of Git. GitHub is a platform. It adds a few things that are actually not part of Git. One of the things that it adds is, well, not everyone should be allowed to change the main branch. You can do those kind of things. Up to you. If you create a repository in GitHub, then you get some additional things. You get settings. You can make it public, or only you can see it. You can invite other people who can see it. But that's all part of GitHub. That's not Git. So the basics is Git. Now you know enough to work with Git. The other thing is with GitHub. And then it matters a little bit. If your company uses Azure, but not GitHub, then those things work a little bit different, assigning permissions. But the Git concepts are always the same. You always do push and pull for synchronizing, and commits. All those things are always the same. Something else that Git gives you is this, issues. This is a very simple example, but for example, what we could see, if we want to look into a real life example, Pandas is a library that we will use in Python. And Pandas is something that is free. That's also developed. It's open source, and the code for Pandas is here. It's also on GitHub. So all of these files, it's a little bit more serious than the simple README file, but all of these files together, they are the source code for Pandas. We see that over time, people have made 30,000 commits. And the last commit is actually yesterday. And there's issues. So people actually go in and they describe, oh, I would have liked if Pandas can do this and this. And then someone else picks up the issue and tries to fix it, right? So GitHub offers things to make your life easier, to make it easier for a team of developers to collaborate. And then finally, we also get into pull requests. Pull requests also don't really belong to Git, they belong to GitHub. Right? Just like issues don't belong to Git, but they belong to GitHub. Pull requests as well. Pull request is a way of saying, hey, I created a branch. I think I did something useful. I would want my code to be merged into the main branch. That's a pull request. And then why do we want to do that via a pull request? Well, someone else can open the pull request and see, you can describe your changes, and someone else can then review your changes. Someone else can see, oh, you actually made these 3 commits in your branch. And in total, if I would accept this, then this is what will change in the main branch. And then you see people actually also make comments. They say, oh, are we sure you want to do this? Have you thought about this and this? So these pull requests facilitate code review. You don't need it. What happens behind the scenes is someone makes a branch and the branch will be merged back. That's it. But GitHub says if you do that via a pull request, that's nice. Then you can also do code reviews. But this stuff looks a little bit different if you're not using GitHub. So the Git stuff is always the same, and this stuff looks a bit different. Someone else will call it a merge request. I don't know why. It's just because it's not GitHub. Yeah, I think these are the main concepts that I wanted to explain around version control. So let's go over the questions finally. Let's see, does source tree function similar to Git GUI? Yes, there are many programs like source tree. I like source tree because it's free, and it's actually also, you can use it also in without a license in commercial settings. But I think Git GUI is also a fine program, and there's also other programs. What file types work with Git? All file types, doesn't matter. Git doesn't care. But it works best with files that it knows the contents of. So text files, it works best. But if you would put a picture in there, then Git doesn't know, oh, the picture changed from a dog to a cat. It doesn't know that, right? So then it will just save the new picture. And that's not really how Git is meant to be used. It's meant to be used with text files, but it doesn't really matter. You can put whatever you want. Yeah, so within editors, like VS Code, there is also functionality. So Git Lens is nice functionality inside of VS Code. And the question was, is this the same? Well, it's not exactly, but yes, it offers the same functionality. If you are inside of an editor, then you don't necessarily have to use this program. You can also use a different program, maybe a program that's part of the editor. That's fine. The concepts are always the same. Yeah. And I read that you will be using Git, so that's good. Then you definitely will get practice. But know that if you want, you can just use SourceTree and play around with it on your own computer, and everything is secure, and that's fine. And you don't have to use GitHub. Maybe a final thing, if you do have GitHub, if you make an account on GitHub, then you can also click here and say new repository. So don't put anything on here that you don't want to share with the world. But if you want to get some practice, you can just make a hello world repository here, and that will then be your online place for putting code. Also make it private if you want. I think it's good to have a break, and then we can continue with Python. And then that will also be a session where there's exercises, and it's less me talking to you and more you guys practicing.